everyone. My name is Nalpi Hamlata. I am from Siddharth Institute of Engineering and Technology. Firstly, thanks for giving this opportunity. This research work was completed under the guidance of Dr. M. Giri and team is Nakalani and with my fellow team members' contribution. They are Tala Munikirti, S. R. Kumar and Moldreti Gautam Kumar. The work First, I am representing the work titled Implementation of Edge Intelligent Deep Learning Approach for Management and Prediction of the Disasters using the social media datasets. The main motivation is disaster prediction become very critical and challenging, but due to the rapidly increasing the environmental changes, as also existing approaches and systems and stuff relying on and relying on the centralized cloud architecture, which leads to high latency and poor early detection, delays the response. It's very difficult. And also, all the existing systems are facing the struggles with handling the noisy data from the multiple sources like IoT sensor data, social media data, and historical data set. So, to solve these problems, we are introducing a system uh, that is only edge intelligent deep learning systems for the prediction and management. The objective is developing a deep learning based network for disaster identification, prediction, and management, which minimize the latency and reduce the rely on the centralized cloud architecture. And also, we using the edge computing and the cloud computing and deep learning. Edge computing is used for the fast preprocessing because which is reprocess the data near where the data is generated, and cloud is for advanced analytics and global coordination, and deep learning of model is used for the identify the information and important insights and predict the disasters, which includes the multi-source data, IoT sensor data, social media data, and historical data sets, which improves the robustness under the noisy and heterogeneous data environments, which also performance very high and compared to the existing prediction approaches. We can see in this image the flow of execution also. We are getting input from sensor, social media, and historical data. We are pre-processing data using the edge computing from initially. After that, we are sending the data to the cloud for advanced analytics. And this in this multiple stages will be there. First, data cleaning. After that, we are removing noisy data, irrelevant data, and this and all data is we are removing. After that, future extraction, important information and insights. And then we are fishing the futures. After that, using the deep learning model to predict the disasters, which is very helpful, and it will very helpful where very helpful when using the real-time data streams and we give the instant real-time insights and alerts. It is very helpful to get the reactive actions. Also, key results. IDLPD achieves the highest accuracy of 95.81%, outperforms all existing disaster prediction models. Can see in this graph, IDLPD which is performs better than the other existing systems, and our model attains super precision 95.22%, which means we are reducing the fault detection predictions, and it shows improved recall 94.63%, which ensures better reduction, and we have high F score of 94.92% indicates balanced performance between the precision and recall. The model records the highest accuracy value 97.7%, very under value, which demonstrates that it will be the strong, it will have strong classification capability. You can see in the graph, and it maintains the consistent performance across the multiple conditions like low, medium, high, and the critical disaster conditions. I'm concluding it with developing an edge intelligent deep learning framework IDLPD for real-time disaster prediction and management, which reduce the latency and dependency on the cloud architecture and improves the robustness and scalability, which is integrated by the edge computing, cloud, and this and all deep learning, and also with multiple data sources like IoT sensor data, social media data, historical data, which robust the disaster prediction system. This integrated fusion enables low latency and noisy resilient disaster prediction in dynamic environmentals and in increasing environmental changes. So it is very helpful to proactively take action and getting the alerts so that we can predict the disasters in at early stage. So we can, it is very helpful to everyone. So thank you for this opportunity. Thank you.